For this next section, we are given the function f of x equals x squared minus 6x plus 15, and we are asked to find function values of that function. So the first one is f of negative 3. So notice that the negative 3 isn't in place for the x. So every time I see an x, I'm going to plug in a negative 3. Now I'm going to use my Pemdas. So the biggest mistake people will make on this is misusing their Pemdas. So as a reminder, PEMDAS means P for parentheses. So you need to do all the inside the parentheses first. E for exponents, then M and D are in the same step. Multiply and divide, you're going left to right, which is why the arrow's there. And then the last step is add and subtract, again left to right. So just make sure you're using PEMDAS in the right order. P parentheses. Inside the parentheses, I can't actually do anything. There's only a negative 3 inside the parentheses, and I can't do anything there. So E exponents come next. Negative 3 squared is positive 9 because negative times a negative is a positive. Then I go to my M and D step, left to right. If there's any multiply or divide, I do it. Negative 6 times negative 3, that's positive 18. Then I go back to the beginning and do my AS step. Add or subtract left to right. So 9 plus 18 is 27, and 27 plus 15 is 42. So therefore, f of negative 3 is equal to 42. Some people are going to ask me, well, what if I just put 42 and not put f of negative 3? And that's fine, but the most appropriate way to do it is write f of negative 3 equals 42. So the next one, every time I see an x, I'm going to stick in a 0. So I have 0 squared minus 6 times 0 plus 15. Parentheses, can't do anything there. E exponents, I'm squaring 0. 0 squared is 0. Then go back and do all my multiply and divide. Negative 6 times 0 is 0. And then add left to right and get 15. So therefore, f of 0 is 15. If you just write 15, that's fine. The next one is the easiest one of them all. F of a. I know a lot of people get scared on this one, but it's really not that bad. Anytime you see an x, you just plug in an a. So a squared minus 6a plus 15. Now, there's nothing to reduce here. There's nothing to combine like terms. You are done. All you're doing is replacing one variable with a different variable. Now, the last one is probably the hardest one of all of them. When you're doing f of a plus h, I want you to take a plus h and plug it in wherever you would have saw an x. So x squared gets replaced with a plus h squared. Minus 6x, but instead of x, you're putting a plus h. Now, when you square a plus h, that means you have to take a plus h times itself a plus h. And then do a bunch of distributing. I'll distribute the 6 as well. So a times a is a squared. A times h is ah. H times a, that's ah. H times h, that's h squared. Minus 6a minus 6h plus 15. And then these two can combine like terms. So we have f of a plus h is equal to a squared, that's the first one here. AH plus AH. Notice there's a 1, there's an invisible 1 there. So if you have one AH plus another AH, that's two AHs. Plus h squared, got that one, minus 6a minus 6h plus 15. And all of that is your answer. Okay, for the next section it says perform the polynomial operations. So add, subtract, multiply, or divide, whatever it tells you to do. On this first problem it says subtract. I'm taking this first polynomial and I'm subtracting the second polynomial. Notice the operation in between is subtract. So I'm going to take that negative, or negative 1 if you will, and distribute it amongst the whole second parenthesis. So all of the terms inside the second parenthesis change sign. The biggest mistake people will make here is they'll see the parentheses and they automatically want to just distribute like PEMDAS, and then they're like, well, miss, this was a really long problem. Well, that's because you did it wrong, okay? I wasn't going to make you do that big of a problem. I was just trying to get you to subtract the two parentheses. Very simple, but a lot of people make this way harder than it has to be and get the whole problem wrong because of it. Alright, here. So now all I'm going to do is combine like terms once I've distributed the negative. 6x cubed minus 1x cubed, that gets you 5x cubed. The next like terms are negative 3x squared. And oops, I dropped a squared right here. I'm sorry about that. That was supposed to be a negative 2x squared. Please forgive me. So negative 3x squared minus 2 more x squared is negative 5x squared. Okay, the next term is x. So x doesn't have another x on the other side, so that one doesn't have any like terms to combine with, which is fine. It's just one term. And then the last one is the numbers. So I have negative 11 plus 5, and that gets you negative 6, and that is all. Okay, it didn't need to be that difficult. Don't try to distribute there. The operation in between tells you to subtract, so that's what you do. On our next problem, we do have to multiply. Notice the 5 and the parentheses are right butted up next to each other, whereas the two parentheses on number 11 aren't. The symbol between them has a minus, so that's why you would subtract on 11, where on number 12 you have to multiply first because the 5 is right next to the parentheses. So we have 10x minus 15. I'm also going to distribute the 4. 4 times 3x is 12x. 4 times negative 1 is negative 4. And then I'm going to combine like terms. I have two terms of x's, which get me 22x. And then I have two terms of numbers, and negative 15 minus 4 is negative 19, and that is all you do on that one. Done. Number 13. Notice that the two parentheses are right next to each other. That means multiply. Unlike 11 that had a minus between it, number 13 has a multiply because the two parentheses are right next to each other. So I'm going to distribute. I'll take the 2x and distribute it to both terms in the other parentheses, and then I'm going to come back and grab the negative 7y and distribute that to both parentheses. So let's do the red distribute first. 2x times 3x is 6x squared. 2x times negative 1y is negative 2xy. Now I'm going to come back in green and grab the negative 7y and distribute that. Negative 7 times positive 3 is negative 21 xy. Negative 7 times negative 1 is positive 7. Y times y is y squared. And at this point I'm going to combine like terms here in the middle. So the 6x squared just comes down. It doesn't have any like terms, but the xy and the xy can combine, and that makes negative 23 xy. Remember that the variables stay the same, the coefficients add up. The 7y squared doesn't have any like terms, so that just comes down, and you are done. For number 14, when we're squaring a binomial, you need to remember that what you cannot just take the 2 and distribute it through. You're not allowed to do that over a binomial, only a monomial. So I have to just write out 5x minus 1 twice. So we have 5x times 5x, which is 25x squared. 5x times negative 1 is negative 5x. Then I'm going to come back in a different color here. Negative 1, and negative 1 is going to distribute to both, so that gets you negative 5x, and negative 1 times negative 1 is positive 1. And again, it looks like those two middle ones are going to add up. So the 25x squared is just going to stay 25x squared. The negative 5x and minus 5 more x does not cancel out. They add up because they're the same sign. They add and keep their sign, so that's negative 10x. Notice the variable doesn't add up, it just stays the same. And then plus 1 comes down. Okay, for 15 through 18, we have two functions, f and g, and we're supposed to add, subtract, multiply, and divide, which is very similar to what you were just doing on the last several problems, except we have to interpret it in g and f. So you're just plugging in the functions. I'm going to do all my g's in red and all my f's in blue, just so we are sure you understand what's going on. So this blue f becomes 8x minus 1. The operation between them is a plus, so I'm going to put a plus in black here. And then the g I'm going to do that in red, which is negative 3x plus 4. So because I'm just adding the two functions together, I just combine like terms, and that's going to get me 8x minus 3, that's positive 5x. Negative 1 plus 4, that's plus 3. And that's my new function 5x plus 3. For number 16, we have f of x minus g of x. So the f of x is going to be 8x minus 1. The sign between them this time is subtract. So I'm going to have a subtract in black. And anytime you have a subtract, you need to put parentheses around the thing that you're subtracting. And the thing that I'm subtracting is g of x. So I'm going to put the g of x, which is negative 3x plus 4, in parentheses. The reason I need to do that is because I need to subtract all of the terms of g, not just the first one. So that means I have to distribute the negative through, which negative times a negative gets you plus 3x, and negative times a positive 4 gets you negative 4. And then I'm going to combine like terms, and 8x plus 3x, that's 11x. Negative 1 and negative 4, that gets you negative 5. And there is my new function for f minus g. For number 17, we have g of x times f of x. So we have g of x in blue times g of x in red. And so this is just to distribute, so we have to distribute here. So we have negative 24x squared, because 8 times 3 is negative 24 here, plus 32x, and then I'm going to come back and grab the negative 1. Negative 1 times negative 3 is positive 3x minus 4. The two middle ones can combine to get 35x, and the first term and the last term stay the same. And there's my new function for f times g of x. The last one is f divided by g of x, which I think is almost the easiest one here, for the first half of it anyway. The f of x goes on top, 8x minus 1. The g of x goes on bottom, negative 3x plus 4. There's nothing you can do to reduce that, so there is half your answer. Now there's this other little note here. It says give the restriction. So the restriction means if you've created a fraction, you've created a problem in the bottom. You cannot have a function have a 0 on the bottom. We can't divide by 0. That's just a big fat no-no. So what we're going to do is we're going to take the g of x, which was in the bottom, and we're going to set it not equal to 0 so we can find out what the one bad value would be. So the g of x that I know that I put in the bottom is negative 3x plus 4. I know that the x value, that if I plugged it in there makes the whole bottom 0, would be invalid. So what I'm going to do is I'm just going to restrict the function from even being defined at that point. Once I solve this, I'm getting x is not equal to positive 4/3. Okay? So in addition to this answer, I have to let the reader know that this is true, that f of x is equal to 8x minus 1 over negative 3x plus 4, as long as x is not equal to negative 4/3. Let me make that just a little bit more clear here. And that is it for number 18.